Let's solve question 30 now. So suppose that it becomes possible to perform a test that gives credible information about the quality of the car. Now the test indicates whether the car has high quality, which is above 1/2, or low quality, which is below 1/2, and there are no costs involved in the test. So all cars above this level will be traded in equilibrium. Is that true or false? Okay, so we have this data over here that above 1/2 we have high quality cars, and I drew here the distribution between 1/2 and 1. Now the question is, why do we consider only this part of the distribution? Why don't we consider everything starting from 0 as we had in the previous question over here? We considered the distribution starting from 0, and the reason for that is because now we can screen it, so the consumers, the buyers, know whether the car is good or not. And if the car is good, they obviously would like to buy a good car. So customers would like a good car. Customers would like a good car. And that would mean a quality above 1/2. So that's the first step. Now the customers, the buyers, still don't know exactly what is the quality of the car. All they know that it is above 1/2. In other words, the price that they're willing to pay is going to be an average valuation of this range, the average valuation of the quality between 1/2 and 1. So let's calculate that. The price of the buyer would still be equal to the average valuation on this range, and that would be the following. We will keep in mind the valuation of the buyer in this question. So let me just crop them from the previous video and drag them below. We have this data over here. We'll actually need all of this, so let's just copy and paste it below like that. Okay, so we start calculating the price of the buyer, the price that the buyers are willing to pay. That would be based on the average valuation, and we said that we're considering the valuation of the buyer to calculate that. So we have 2 multiplied, what's the minimum quality that we consider? 1/2. So 1/2 multiplied with V plus B, and then on the other side we consider the maximum value that we could get, the maximum quality, which is 1. So that would be 2 times the quality of 1 times V plus B, and all of this divided by 2. So all of this divided by 2. Now 2 and 2 cancel out, so 2 and 2 will cancel out, and what do we have? V plus B, right? We have V plus B, and over here we have 2 times 1 times V, which is 2V plus B divided by 2. And then if we work this out, what do we have? 2V plus V, which is equal to 3V, plus B plus B is equal to 2B divided by 2. And if we divide each term by 2, what do we get? We will have the following: 3V divided by 2 plus 2B divided by 2, which is equal to B. Okay, so we found out the price that the buyers are willing to pay. Now, what would be the price? What would be the price that the sellers are willing to sell? And remember, the key word here is going to be the following. The key word is that all cars with the quality above that level will be traded in equilibrium. Now, to trade all cars, it means to sell all cars. And if you want to sell all cars, it means we have to sell even the cars at the top, the cars with the quality of 1. So the valuation of the seller, if the seller is willing to sell all cars, including the best one, he must get his price for it. So the price of the seller will be based on this quality of 1, and that will equal to 2 times 1 times V. We're substituting into his valuation formula. So that will be equal to 2 times 1 times V, 2 times 1 times V, and that's just equal to 2V. Okay, so if that is equal to 2V, and we also know the valuation of the buyer, the price that the buyer is willing to pay, we know that we trade cars. If the price that the buyers are willing to pay is at least the same as the price of the seller. So if the willingness to pay compensates the seller willingness to sell. Now what is the price of the buyer in this case? We found it out over here. That's 3V/2 plus B. So we will have the following: 3V/2 plus B must be greater than or equal to 2V from here. Now if we solve this, what do we have? Let's take the V's on one side and the B on the other side. We'll take this over there so that we have 3V/2. Actually that's gonna be negative V, so let's do it in the other way. Let's take 3V/2 to the right. Yes, let's take 3V/2 to the right, so that we have 2V minus 3V/2. And what is 3V/2? That's 1.5V, right? 3/2 is 1.5. and that must be less than or equal to B. We're leaving B on this side. So what is 2V minus 1.5V? That's 0.5V. In other words, 1 over 2V. And B must be greater than or equal to that. B must be greater than or equal to that. In other words, if this condition is satisfied, then all cars are traded. All cars. This is the key word. But if we go back to the question, in the beginning, it is given to us that B must be less than 1 over 2V. B is less than 1 over 2V. That is just a given. And in our case, we saw that B must be greater than or equal to 1 over 2V, which is impossible by definition. In other words, it is not possible to trade all cars. So not possible to trade all cars with the screening. Not possible to trade all cars. So if we look at the answer key and they say that if that holds true, then all cars will be traded. No, that is false. It's not possible. And we are done.